With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone. So let's see this question. In this question, it is given that which of the following is correct order of basic strength for the given compounds. So we know very well, right, that aliphatic compounds are more basic than aromatic compounds, right? This is very important thing which you should remember, that aliphatic compounds are more basic than aromatic compounds, because in aromatic compounds the electrons are evolved in resonance, so the delocalization takes place. So from this line we know very well that first and second compound is going to be more basic than third and fourth, right? Now let's see in between first and second which is more basic. So first of all, what is basicity? Basicity basically is directly proportional to basicity is directly proportional to availability of lone pair of electrons, right? So it is directly proportional to availability of lone pair of electrons, or you can say tendency to donate electrons, right? So it is directly proportional to the tendency to donate electron. Means more is the tendency to donate electron, more will be the basicity. So you can say that if lone pair electron is involved in resonance, if it is involved in resonance, then availability of electron decreases, right? So if the lone pair of electron is involved in resonance, then the availability decreases because the delocalization takes place, and therefore the availability of electron decreases. It means that basicity decreases too, right? Basicity decreases too. Now let's see that what is given to us, the compound given to us. So in the compound 1, you can see very well that in the compound 1, this nitrogen, the lone pair on this nitrogen atom and the lone pair of this nitrogen atom, it is in the double bond here, double bond, and the lone pair on this nitrogen atom is evolved in resonance, due to which the electron density at this nitrogen will increase. What will happen? The electron density at this nitrogen will increase. Let's draw the structure. It is like CH3, C, double bond, NH, and finally you have NH2 here. So what I am telling, that the electron density at this nitrogen will increase because the lone pair of electron at this will increase the electron density because it is in conjugation with this double bond. So you can say that one is most basic. Yes, because the availability of electron increases, and if availability of electron, one is most basic, because if the availability of electron increases, the basicity increases. So one is most basic because of the more electron density here, right, at this nitrogen atom, because the lone pair of electron of this nitrogen atom is increasing. So one is most basic. Now let's see about second. In case second, you can see there is plus I effect, right? There is plus I effect of this CH3. So the plus I effect also increases the electron density at the nitrogen atom. So that is also going to increase the electron density and availability of a lone pair of electron. But that will not be as much as it was in case 1, because in case 1, due to resonance, more availability of electron will be there. So we will write here that one is more basic than 2, because in 1 the availability of electron increases due to resonance, while in 2 the electron availability increases due to plus I effect, right? So this is important, that 1 is more basic than 2 because in 1 the electron availability increases due to resonance. So you will write like this: 1 is more basic than 2, right? This is the important part. Now let's see what is happening in the third and fourth part. In the third part, the compound given to you is, you can see here, a phenyl ring, and then you have the NH2 group attached here. And here also you have the same thing, but just at ortho position CH3 group is attached. So when it comes to the ortho position, let's study about ortho effect. Now what is this ortho effect? Whenever you have NH2 group attached at this top position, and then at this position if any group, let's say G can be any group, attached, can be any group. For example, let's take it as CH3. So now what does the ortho effect says? According to this ortho effect, the basicity of this compound decreases because the group is attached at the ortho position. The basicity, any group, if it is attached at the ortho position, the basicity of this compound decreases, and hence you can say that if you take a normal aniline like this, right? If you take a normal aniline like this, here you have NH2 group, and if you name this as 2, and if you, let's take this was 3, and let's name it as 4. So you will always say that the basicity of 3 is going to be greater than the basicity of 4. This is the basicity order because of, you can say, because of ortho effect. Because in 4 you have a group attached at the ortho position, and due to this group which is attached at the ortho position, the basicity of this compound will decrease. And why it is decreasing? It is due to the steric hindrance. Because of the steric hindrance of this G group, the basicity decreases, and that's why we say that this is the order. So this is the order, that 3 is more basic than 4, right? So now let's write down the final order. We have already discussed that aliphatic compounds are more basic than aromatic compounds. So that's why we have already discussed that 1 was more basic than 2, right? And after this you need to say that 3 will be more basic than 4, right? Because of the ortho effect. So finally this is going to be the order, the final order, that 1 will be more basic, the final order of basicity, right? That is how. Let's see the compounds once again. So we have already discussed that why 1 is more basic. We have discussed 1 was more basic due to the resonance, making the availability of electron much higher in 1. Then 2 was less basic than 1 because of the plus I effect, so 1 was greater than 2. And then between 3 and 4 we discussed that 3 should be more basic than 4 because in 4 there is ortho effect. So we have written it that 1, then 2, then 3, then 4. This is the final answer, right? I hope you have understood. Thank you very much.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.